Hello everyone. Welcome to the Module 4 instructor presentation. Once again, this is Antonio Lavragetta, one of the course designers. And we're, at this point, if once we get through Module 4, once you all have completed Module 4, then you'll be halfway through the course, so that's great. We're getting there. Once again, the point of these presentations is to, of course, go over some of the content, but also really go through the themes and some of the major themes and concepts of each of the modules and so forth. And you can see that really what this particular module is about. I think you can get the idea here. It's about attention. And this is interesting because when I took the course so long ago, I guess at this point, when I was an undergrad, there wasn't even a chapter on attention if you took a perception class. Since then, in the years that have passed, there's been a lot more research on the role that attention plays, and so now it has its own chapter, which is great. Here are some of the themes, though. You can see here that attention is selective. That's definitely the case. It's absolutely essential for complete and holistic perception. We're going to see that, and you often, just think about your real life. I mean, your just everyday life, or just think about when you're raised. People are constantly telling you, pay attention to what you're doing. Otherwise, you might not do things properly. Attention really is something that is absolutely essential to perceive, to not even just perception, but for recognition, for proper responses and such. Now, with advances in physiology and in functional MRI and other types of neuroimaging, we can see that attention has a direct impact on how the brain works. So attention can actually influence physiological properties of neurons. It can influence brain activity and so forth. And finally, just this last one here is that attention is limited. This kind of goes along with the fact that it's selective. It is truly a resource. It is limited. And I want to address the myth that human beings can be really good multitaskers. You'll see that's really not the case. That's not the case. But let's go forward here. First off, in your text, spend some time studying the saccadic eye movement, the material on saccadic eye movements. Often students are not aware of what these are. If you didn't know this, our eyes are constantly moving. So you can, of course, direct. Like I'm moving the mouse here, you can direct your eyes to track that mouse or whatever. You can obviously have direct command over it. Even if you think your eyes are even if you try to fixate on something, like if you want to fixate on this S right here, you can do that, but your eyes are still going to twitch around. And this just happens. And these saccadic eye movements are quite normal. And they're essential they're actually essential for perceptual activity. But one of the things your author goes into is showing you saccadic eye movements, and there's actually software that can track eye movements, so we can see precisely what people are looking at, and that's going to turn out to be important. And this is all part of the visual scanning. What do we tend to look at? What do we tend to fixate on? Also, the distinction here between overt and covert attention bears some mentioning. So overt, just like it says, it involves looking directly at a particular object. Covert is paying attention to something without directly looking at it. So if you're looking forward watching television, but there's someone in your periphery off to the side there, to the right or left, and you're kind of thinking about them, but you're not really looking at them, that's more of a covert attention. Okay, you might very well direct your attention overtly to that person. But it's there. Or just imagine if there's like a little bug in the room, and it's just sort of flying around there, a gnat or something, and you're just trying to focus on the television. You know it's out there, and that would be more of a covert attention activity. Both of these types of attentions are used in research. They're used in different research paradigms. What directs our attention? I said that attention is selective. And attention, you'll see, is a resource. So we have a limited amount of this. So it's kind of interesting in the sense that certain elements of a scene, certain characteristics of the scene, or certain characteristics of the objects can capture our attention. That's called attentional capture. So for example, if something moves, that can serve to capture our attention. So if you're sitting there as you're watching television, if in fact there's movement, In your periphery, that is, and then you fixate towards it. That would be an example of attentional capture. Um, and so there's lots of different things that could do that. It doesn't have to be movement, but anything that's really obvious or it tends to be very, this salience, here, the visual salience. If something is quite salient, it means it's very noticeable. It could be a very bright color, something that gives high contrast and things like that. Um, Areas of the stimuli that attract attention due to the properties of the stimulus. We think about with children, a lot of the cartoons that are used for marketing purposes, for let's say if we're talking about cereals and whatnot, a lot of times the colors are very bright. The characters are there's a lot of exaggeration. Just think of a Pixar movie. The characters, there's an attempt there by the creators to constantly keep the attention of the children, and so forth. So anytime you have a very salient stimuli, you can do that. Otherwise, we might drift our attention somewhere else. But here you can see, this is in the book, if you look at this picture, what tends to get your attention right away? Well, it's this sort of uniform looking group of people here. They all kind of look quite similar. A lot of them are wearing sunglasses, or a lot of them are wearing white. But here we go. Here's this fellow there in the red. This is a salient feature because it's different than everything else. All right, so that's an example of capture due to salience. Also, here's a typical, what psychologists often do to study this type of thing with attention. They'll use these visual search tasks. Without even telling you anything, you probably, just looking at this field here, this object here, this red diamond, I'm sure captured your attention. It's different than everything else. All right, so these type of stimuli can capture our attention. Cognitive factors can influence attention. Okay, so this meaning, we talk about semantics, our prior knowledge, or what's called that schema again. Once again, cognitive psychologists refer to schemas. These are knowledge bases that we have about things, can influence what we tend to pay attention to, what we tend to fixate on. And this knowledge is usually just gained through just your typical life experiences. So this is an example, once again, of top-down processing affecting our saccadic eye movements, essentially. So what, you've developed a schema for driving, no doubt. You all drive, you get on the car, and you kind of know what to look for as you drive. You kind of know where all the road signs are. You know where where your display is in your car, all the important things. You know what's going on there, and that's all going to tend to direct what you tend to saccade your eyes towards. Okay, so your fixations in that context are influenced by that knowledge. And that's an example of top-down processing. And here you can see, this is in your text, the Shinoda experiment. Observers' fixations were measured during computer-simulated driving. And here, what they found was they were more likely to detect stop signs when they were where you would imagine them to be. And most stop signs are found at intersections, right? If the stop signs were placed in areas that were not intersections, essentially, in this computer simulation, almost like a video game, essentially, they didn't tend to fixate on them as much because they're not looking for them. So what we find when you look at the texture, what you'll find is that there is sometimes sometimes if an object is placed where it's consistently where we tend to find it in the environment, if it's consistent with that, sometimes it's more likely to be noticed, and sometimes it's not. It's kind of interesting. The research is sort of mixed on this, but in this, what they happened to found was that when the stop signs were placed where you'd expect, then they tended to notice it more. Here you can see a different experiment by Henderson there, Vo and Henderson, 2009. In this case, we have kind of the reverse. Okay, here we see, and this looks like it could be sort of a kitchen setting almost. It looks like a kitchen possibly, where we have, it looks like a range of some sort. There's some cabinetry and stuff like that. And here, on the bottom, of course, we have a pot, which is something that you'd expect. But in this case, a printer is there. And here we see subjects spend more time looking at the printer than the pot. So sometimes putting an object that's unusual, okay, an object that's unusual can actually be more salient. So it's sort of mixed, the evidence there about, expectation effects, essentially. Okay, let's see. Yeah, another one here, excuse me. Um, Attention can be influenced by a person's goals. All right, so I mentioned the example of driving. So when you're driving, you definitely have a particular set of goals there. You're trying to get to a destination, so that's going to tend to influence what you tend to look at. Once again, there's that eye movement tracking right there. Your goals can influence what you look at, and this is shown by this is some examples in the book. So if I in this particular study, this is an older one, but if you instruct people to look at this painting, depending on what you tell them to look at in the painting, you're going to get different types of eye movements because their goals are different. So it seems pretty reasonable there. You can see here, for example, for B, they had to estimate the ages of the people in the painting, and notice how they're focused on the heads, it looks like. All right, but if I give them different tasks, I'm going to tend to look at different things, which seems to make sense. This is another one here, looking at if, sequence of fixation of a person making a peanut butter sandwich. All right, so here we see if I have to make a peanut butter sandwich, I got to, first you got to look at the bread, then you're going to be looking over here at the sandwich itself and spreading the peanut butter and so forth and so forth. And excuse me just for a moment here. Pardon me. So, excuse me. They're having to look at, these are just the sequence, the eye movements here, the fixations. Obviously, you've got to direct your attention on the relevant objects that you need to do to complete this particular task. So what are the benefits of attention? Well, it's one of the nice things about selective attention. When I mentioned earlier as a theme that it's selective, it means that we're really kind of we're able to ignore aspects of the environment at that time, so we can focus on the task at hand. And if we're focusing on the task at hand, does that change how we look at things? Does that change, for example, of how salient that stimulus might be? And this is kind of interesting. Posner was a psychologist. He was a cognitive psychologist who did a lot of work, particularly back in the 1970s. He had observers look at a fixation point, and this is shown here. So this would be a fixation point here. They look at a fixation point, but then they have to pay attention to cues that were off to the side here. Okay? And he did something called a pre-cueing task, and in this case, it would be an arrow. And the arrow would basically, this pre-cueing task would essentially tell them how to direct their attention. So you can see here, and this would just be flashed very briefly. So for example, in this one, this pre-cue is an arrow, that's directed to the right, and then a target would emerge. And sometimes the target would be consistent with this cue, and sometimes the target would be in the opposite direction of the cue. And we call that valid versus invalid. Okay? So this pre-cueing with an arrow indicated on which side a stimulus was likely to appear. Stimuli that appeared that were consistent with that, arrow, or stimuli that were consistent tend to respond faster. Okay? So observers responded fastest on the valid trials. And, just to let you know, so you can see valid, they tended to respond quicker than invalid. All right. So their performance increased when their attention was directed properly. All right. So that's what they're talking about here. Attention can actually enhance our speed of processing of information. So once again, it's good to know. Often you think about this in your own life. If you have a good goal, if you know what you need to focus on, that's going to enhance your attentional capabilities. All right, and this is all, once again, this notion of the speed of processing is consistent with this, a spotlight. We can narrow our attention onto what this is often the metaphor, the spotlight theory, that we can narrow our attention, we can focus in on that, and that's going to enhance wherever that spotlight is at the time, so to speak. All right, so that's the speed of processing approach there. Another thing that's interesting is that attention can actually influence the appearance of a particular object, and this is This was done by this experiment to support this idea was done by Carrasco and all. Here, Carrasco had subjects look at grading stimuli. Okay, and the grading stimuli are shown here. All right, so there's some grading stimuli. These are alternating bars of light and dark, lightness and darkness, essentially. This is a stimuli, by the way, that's used a lot in perception research. The perception research, when this particular stimulus can be controlled quite nicely, because basically, if you look at this, just to give you a tiny bit of background about this, I can make these bars either really bright, I can make them really contrasting so that the dark is really dark and the white is really intense, or I can essentially make them to the point where they're grayed out. Anyhow, that's called a grading stimulus. And they saw these two different grading stimuli. Okay. The task was to fixate on the center point between the gratings, and you can see there's this center point right there. All right, there's a fixation, and then they would flash a little cue once again to kind of direct the attention. So let's say the cue was flashed on this left side. Then they present the stimuli, right? On certain trials, if they presented this cue on this left side, this left stimulus became more salient. So they'd have to basically judge which one has more contrast here, the right or the left. If a cue, like in this case here, was flashed on the left, it made them direct their attention more on this side of the screen. And then when the subjects were asked, well, which one of these gratings is more contrast, or are they the same, or whatever the case, they would report that this side seemed to have more contrast, even if the two stimuli were identical in actual contrast settings. Because you can precisely control this kind of stimuli. That's why it's a good one. If that cue was not present on the trial, then they would report, oh, they're both, they both have similar contrast. So attention can actually influence the appearance of an object. If we focus our attention on something, it can be more salient to us, which kind of makes sense if you think about it. Attention can also influence physiological responding. It can actually influence how the neurons work in the brain, and this is something that is one of the more important concepts in this particular chapter. Here, this is a stimulus where it can alternate between a house and a face, and you've already learned that different parts of the brain tend to respond to stimuli like faces, and different parts of the brain tend to respond to structures like houses. And yeah, the parahippocampal place area tends to respond more to structures like buildings versus the face area. The fusiform face area tends to respond to faces. Well, if the subjects in these studies were to attend to the face, we're told, all right, here's this stimulus here. It's like this weird-looking compound stimulus, but I want you to focus in on the face. Well, all of a sudden, yeah, the PPA is going to show some activity, but the face area is now elevated. And then if I tell the subjects, all right, I want you to focus more on this structure, well, then we see the reverse happen. So it's kind of interesting because even though the stimulus is there, attention can modulate the activity of the brain, of certain parts of the brain, which is interesting. All right. Also, we can see changes in receptive field organization based on attention, things of that nature, and that's shown here. Receptive fields can change. We could see another particularly important area is that general activity of the brain, in terms of there's what Bozeman, and this is all in your textbook once again, so look at this again. So Bozeman and colleagues found is, all right, communication through coherence. A lot of neuroscientists are interested in how is it that different parts of the brain work together. All right, well, one possible mechanism is this sort of coordination or synchronous activity might be a signal that different parts of the brain could be acting in a more coordinated fashion. All right, and that's more or less what we're seeing here. And this is a study here that you could see what Bozeman found using monkeys is that, well, if you have the monkey, do a task that's going to require different parts of the brain, when the monkey is forced to attend to certain types of stimuli, what'll happen is um, we get more coordinated or synchronous activity. And that's what's shown shifting from B to C. So once again, when the monkey is forced to attend to particular types of stimuli that require multiple brain areas for accurate perception, notice how here we get what you're seeing is two different brain areas and seeing how much their activities tend to overlap, where the green represents activity of one particular brain area, and then this orange represents activity of another. And it's not perfect, but there's general overlap. And we see this overlapping only after attention is engaged by the animal. So attention might very well serve to cause more of a neuronal synchronization of areas, all right, which is an important mechanism. And this relates to binding, okay? Process by which features are combined to create perception of a coherent object. And this is, something that we spent some time in this module discussing. For example, I'm not getting into in this particular presentation to the feature integration theory, but that's something else that there's a separate activity for that. Um, the question here is, though, that features of objects are processed separately, different parts of the brain, right? But yet you experience it as a unified whole. So once again, here's an example. The ball is rolling. There's lots of different parts of the brain that tend to play a role in these different aspects of perception, yet it's all integrated. And so possibly, and what many psychologists and neuroscientists have argued for years, is that attention is the binding mechanism. It tends to help bind all these things together so that we experience a unified perception. And part of that might be achieved physiologically through this sort of synchronization of neuronal activity. At least that's the idea. And some other things here. Okay, moving right along, we have some interesting stuff that I like to show, that the role that attention plays. I said attention is absolutely necessary for perception. Inattentional blindness and change blindness, and this is sort of interesting. You could have a stimulus right in front of you. There could be a person right in front of you, and if you're not paying attention to them, you might very well be completely blind to them. Inattentional blindness. Very interesting. And we're also, often blind to changes that occur in the environment around us. I mean, there is a lot of information coming in, into our visual fields, and there's a lot of stuff there that, quite frankly, is just not all that relevant. And you can, once again, you can read through this here. This of course going to the Simons and Chabris work back in the 90s. The elephant and literally the elephant here. These folks have been studying this for years, and you could have, in this particular case, this is one of the famous ones. You've likely seen this one here in an intro to psych class or whatnot, where you could have this gorilla is walking by, and if you have subjects pay attention to a particular task, so their attention is directed at something else, they literally might not see the gorilla walking by. We're blind that these things occur. All right, we're blind to change. And I have you also in the course here think about looking at movies or whatnot, or television shows. There's all kinds of things that change as you're watching a TV show that that we're just not even aware of, and it's kind of interesting. Sometimes you can spot things like that, but it's difficult to do that because you think about it. A lot of times we're focusing on the meaning of a scene. We're focusing on the meaning of events around us, and because of that, we don't tend to notice the details. And, that's important because that means that when we're trying to recall information, when we're trying to, this affects our memory because our perceptions are altered before we even remember the stuff. So this all kind of, I always like to say, this has, applications in things like eyewitness testimony, because, it's human beings are not. We don't record things like your iPhone does. If you want to start recording video, the human perceptual system does not act as a recording device. It's just quite different, and and we're often blind to changes and things like that. So it's an interesting phenomenon to me. At least I find it interesting. This has implications, like I just mentioned, an eyewitness testimony or any kind of, or not even just that in the court um, settings, but also just in your personal experience, trying to remember things. Your memories are they're constructed, they're colorized, so to speak. They're modified. Um, what about implications of driving? Driving requires constant attention. Not only do we tend to modify what's coming in through the top-down processes, um, attention is viewed as a resource, right? And there's only so much of it, and that's referred to as the load theory in your text. Driving requires a lot of attention, and often we're doing other things. I'm certainly guilty of this. I like to listen to music when I drive, and that can serve as a distraction to a certain extent. But then if you get on the phone, that's another distraction. All of these things are taking away that resource. Um, and when you can look in the text, essentially, here's the Strayer and Johnston research back in 2001. Anything that distracts attention can degrade driving performance. And here you can see if folks are talking, right, this would be the reaction time, which the higher is actually worse. This is the time it takes to apply the brakes if you need to. And it's significantly worse than if you're totally focused. All right, and you've probably had that experience. And it's kind of interesting because there's an attempt by the car makers to you have the hands free, and there's different types of technologies we hope helps, but even hands free driving doesn't tend to help as much as you might think. Okay, so yes, we're all, and of course, texting while driving is even worse, right? Because you're having to it's requiring even more load, so to speak, more resource. Okay, so I think that's most of the major concepts again. So once again, attention is selective. It's a resource. That means that, if I'm focusing on something, then that's great. I can really, really learn about that. I can really learn about that object I'm studying, or that's why when you're reading, you need to really focus. I remember I've had students ask me, "Oh, can I read while I'm watching TV?" And this, I read best if I'm listening to music. Well, I'm not going to argue with folks, but no, probably not. You probably need to just focus completely on what you're doing. It's absolutely needed for perception, and it can enhance our perceptual experience. It can influence activity of the brain. It seems to be crucial, in particular for the binding problem. And once again, it is a limited resource. Okay, so I hope that helped, and you have a great week.